Hello, forensic science students. I am Mr. Williams, and this lecture we are going to talk about tests in the laboratory that are performed for drug testing. Remember that last week, one of the things that we talked about was confirmatory tests and presumptive tests. Presumptive tests, they tell you that something could be there. It could be the substance you're looking for. Further testing is needed. And then confirmatory tests are that further test that was needed, and it will tell you for sure is that substance present. And so gas chromatography is something that I used to use on a daily basis when I worked as a polymer chemist. I made plastics, basically. And so gas chromatography provides a presumptive identification, but it is commonly used to separate components prior to confirmatory testing. And so you do separate your components. You can identify what they are within reason. So what we see here is a gas chromatography. Actually, it's called a gas chromatogram. That's what the graph would be. Of cannabinoids that were separated using gas chromatography, and basically you separate those substances. And the reason why that is useful, for one, there are many states like Kentucky where hemp is legal, but marijuana is illegal. And the only thing that separates marijuana from hemp legally is these two peaks right here. These are THC. THC is the psychoactive ingredient that gets people high and gives them that feeling of euphoria. Other compounds, they're called cannabinoids. There's a bunch of different cannabinoids, but other compounds are much more useful in terms of medicine and treatments. I do not believe that it is the miracle cure that a lot of people say it is. I think people are just going to profit off of it, so they have a reasonable idea to market it towards you that way. And so they can reliably separate mixtures, but it does not guarantee a suspected substance is present. And so you would run a substance through this machine and say CBD, right? For example, you took something that you knew was CBD, and it would always appear right here on the graph. And so then when you run this suspected marijuana or hemp product, it goes through here. And if you see a peak right here at this location on the x-axis, then you can assume that it is CBD. You can also measure the amount and get the percentage of composition of this particular substance in the mixture that you have by taking the area under the curve. So what do you need to know? You need to know that it provides a presumptive identification, and it is commonly used to separate components prior to confirmatory testing. So if you want to separate your THC because you want to confirmatory test whether or not that is actually THC, then you could just separate that, and it'll be spit out in it'll be spit out at an exhaust port, and then you can do more testing with that. Chemical reactivity testing. Sometimes tests are performed on suspected illegal substances by adding a reagent to test for a chemical change. Chemical reactions may give observable changes such as color changes, bubbling, temperature changes, or formation of solids. And so, well, color changes are the most common field test performed on the spot before you send it to a laboratory to determine, is it even worth testing this? Bubbling could be the difference between mixing a acid with, for example, crack cocaine. Sometimes it's called a free base because they mix a basic material with it, and so it'll react with acids such as vinegar. And on the opposite end of the spectrum, cocaine is it's an acidified version of the molecule. It's the same thing as cocaine, except cocaine has been mixed with something called a freebase, often baking soda, and cocaine is mixed with hydrochloric acid, which is an acid. Yeah, people are consuming that acid when they do that. And so basically, cocaine would react with a base, and so you would see bubbling and fizzing, and crack cocaine would react with an acid, and you would see bubbling and fizzing, and you would see it, change from a solid to a powder to vice versa. But that's how a chemical reaction test would be used. A lot of things you can do with that. Okay, so we got color tests. So it allows the examination of a substance at a crime scene without laboratory equipment. And so we have this like prepackaged bag right here. It's called a Marquis reagent. So basically you would open up this container and you would put in a substance. Okay, so one of these tests is a Marquis test. So if there's heroin, morphine, or opium, or any type of opiate, you mix it in there and it will turn purple. Okay, so we get a color test. Are there other things in the universe that might make it turn purple that are not those substances? Yeah, probably. So that's why this would be a presumptive test. This would turn orange or brown if it is some form of amphetamine. So we're talking about amphetamine, Adderall, methamphetamine. You could probably get cold medicine to react the same way. So this would, again, it'd be a presumptive test. The Scott test is 3 different test solutions. It turns blue, and it goes. So you had the first solution, it's blue. Then you had the second solution, it's pink, and then you had another solution, it's blue. If it has the presence of cocaine, and I'm guessing it would probably work with crack cocaine as well. Um, Again, a presumptive test because it's just change of color. Would other substances in the universe do the same thing? Possibly. All right. I don't know how to pronounce this. Duquesnoy, living. Um, so this is something that tests the presence of marijuana. It's going to turn purple. And over here, we can see there's a test where there is some kind of marijuana substance wrapped in the foil. And you put it in here, it will turn purple. Again, all these are presumptive tests. They are just color tests. And so there is a chemical reactivity test going on in there in some form. You're going to destroy your substance after you have done this test. And so a forensic scientist wouldn't use all of it because they had to keep some for evidence. But what you need to know, these are color tests. They're chemical reactivity tests of the sort, and they are presumptive. Okay, they do not confirm it's there, but it's a pretty good indication that you should do more testing with confirmatory testing. Okay, pH testing. So pH testing, the term pH is a measurement of how acidic or basic a substance is. Most of us are familiar with acids, and we're less familiar with bases. Okay, so a base or a basic substance is a opposite of an acid. So acids, you would think of something that's very corrosive. Well, bases are also corrosive. We would call them caustic instead of corrosive, but it's the same thing. Well, an acidic substance have the pH values of less than 7. So water is a neutral substance. It is a pH of 7. Okay, acidic substances have a value less than 7. And so we're thinking about lemon juice, right? Lemon juice tastes sour. Vinegar would be another example of an acid. Um, those things are often used for cleaning, let's say, soap scum in a shower because it's acidic and it will dissolve all of that soap scum. Neutral substances, pH of 7 as compared to pure water. If you test the water that comes out of your faucet, it's often a different pH because there's a lot of chemicals and stuff added to help purify it and kill off pathogens. Basic substances have a pH value greater than 7, and so you can think of soap, shampoos are going to be greater than 7. You're also going to be thinking about like ammonia, floor cleaners, um, Windex would be things that would have a basic substance. Okay, what you need to know about this, make sure you can tell me the difference between an acid, a base, and a neutral substance, okay, in terms of their pH. Acid is less than 7, neutral, right at 7, basic substances greater than 7. And so, and on a little bit more technical note, pH value measures the concentration of H plus ions in a solution. So acids have high H plus. Okay, this would be called a proton, hydronium ion, and smaller amounts of OH minus ions. So essentially, if you had the H plus and the OH minus, put that together, what do you get? You're going to have H2O, it's water. So acids and bases have the ability to take water and separate water into an ion. Bases have higher amounts of OH ions and smaller amounts of H plus. Okay. And we have a pH scale that ranges from 0 to 14. It can get less than 0. It can be greater than 14, but that would be uncommon in some kind of designer acid in general. And so you can see the stuff that's on the left is acidic, on the right is basic. On the stuff that is on the left, you can think of has a lot of H plus. Stuff on the right has a lot of OH minus. And if you have a career in cosmetology or you want to do hair, this is something you're going to have to know because hair is a little technical when it comes to the kind of products you use. Color tests are often based on the pH of a substance, and pH is a presumptive test. So you can test pH something, be presumptive. There are many things that are acids, many things that are bases. And, you know, there are many things that would have a pH neutral at 7. So, but in general, this would be a color test because you would add an indicator. Indicators will change the test, or indicators will change the color of the test. All right, so some confirmatory tests include separation and identification of individual components of the material. And so there's a machine called a mass spectrometer, sometimes called a spectrometer. So basically, you got a beam of electrons that breaks apart the chemical in a way based on their chemical structures. You bombard it with electrons, and it breaks off into pieces. And you can measure how much these pieces of this destroyed molecule weigh, and then every substance will have its own unique pattern that you see on this graph below. It's a little technical, it's based on atomic weights, but that's what it would look like. This type of testing is very reliable and it's unlikely to give false positives. If this indicates that that substance is present, that is a true and accurate result, and the only way that there was a false positive for this would be that somebody just mixed up the samples in the laboratory. But very reliable, and it's also more expensive, and it requires some technical expertise to be able to do this. All right, this last one, infrared spectroscopy. So basically, infrared is the color right before red. Okay, so we think of the color spectrum of red, orange, yellow, green, blue, indigo, violet. Well, before red, infra means before, and red means red. So before red, there's this invisible light that we can't see. And so if you shine it on a substance, and then the substance will react based upon the chemical bonds that it has. And as it reacts, you can measure its reaction and you will get this graph. This graph you're going to see, it's going to be unique for every single substance, okay? So it uses infrared light to determine the type of chemical bonds in the substance. And then you can piece together with a little bit of study exactly what those bonds are and determine what the molecule is. This is very reliable and it's unlikely to give false positives, okay? And so this is a spectra of amphetamine. This is one of those examples that says GCIR spectra. That means the gas chromatograph IR. They use gas chromatography to separate it, because remember, gas chromatography is a presumptive test. They separate it, and then after they have separated the mixture, they use a confirmatory test to figure out what those separations are. And this is a infrared spectra here coupled with that gas chromatograph. So what do you need now? Infrared spectroscopy uses infrared light to determine the types of chemical bonds in substance. Very reliable. It will not give a false positive. And what you're going to have here is a confirmatory test. That's what you need to know. All right, guys, that's it. If you have any questions, please leave a comment. If please come to class so we can talk about these things and clear up any questions that you have. And well, have a nice day, guys.